today we are starting section 8, but I want to do a radical review before we go into section 8. Okay, so you've simplified radicals before, but some of you have more practice than others in simplifying radicals, so I want to make sure everybody's got a good understanding. Okay, so this isn't like section 8 topic 1 or anything. This is like a pre-section 8. So everybody's heads are up and paying attention. All right, first of all, let's talk about perfect squares. What does it mean to be a perfect square? Well, what do you mean divide it? Not divide, but square root, right? So what's 1 times 1? So 1's a perfect square. What's its square root? 1. What's 2 times 2? 4 is a perfect square. What's its square root? What's 3 times 3? 9. 4 times 4? 5 times 5? 6 times 6? 7 times 7? 8 times 8? 9 times 9? 10 times 10? 11 times 11? 121. 12 times 12? 144. 13 times 13? 169. 14 times 14? 196. And 15 times 15? Too close. 225. You need to have all those memorized in your head. You know those are all perfect squares without a calculator. Okay? You need to know those by heart. So then what would the square root of 196 be? Close. 14. Square root of 169 is 13. So I always remember from 13 to 14. 13 is 169. 14, you switch the 6 and the 9, and that always helps me remember what 14 is. Okay, so have those memorized. Are there more perfect squares than that? Yeah, that's just the first 15. All right, what's a perfect cube? 3 times, right? 3 identical factors make up the number. So what's 1 cubed? That means 1 times 1 times 1. So what's the cubed root of 1? What's 2 cubed? 2 times 2 times 2. So what's the cubed root of 8? 2. What's 3 cubed? 27. 3 times 3 is 9. 9 times 3 is 27. So what's the cubed root of 27? 3. Anybody know what 4 cubed is? 64. 5 cubed? 125. Very good. I would at least know these by heart, okay? The next ones that I'm going to give you, I don't even know by heart. But these 1, 2, 3, the first 5 perfect cubes, you need to be able to recognize those are perfect cubes, okay? 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And then we'll stop there. Perfect fourths is a number that has 4 identical factors. No extra factors, just 4 identical factors. So what do you think 1 to the 4th power is? 1. So what's the 4th root of 1? Notice 1's a perfect everything. Perfect square, perfect cube, perfect 4th, perfect 5th, perfect 6th. What is 2 cubed? I'm sorry, 2 to the 4th? 16. So the 4th root of 16 is 2. What's the square root of 16? 4. Okay. 3 to the 4th? 81. 4 to the 4th? It's 256. 5 to the 4th? 625. What am I on? 6. 6 to the 4th is 1,296. 7 to the 4th is 2,401. 8 to the 4th is 4,096, and so on and so on and so on. I would at least know that 116 and 81 are perfect fourths. You'll see those more than anything. So let's look at the parts of a radical. So does anybody know what the number or terms or whatever that's under the radical called? The part that they have it in the circle with the A inside. What is it called, whatever is under the radical? Anybody remember? It is called a radicand. R-A-D-I-C-A-N-D. A radicand. What is this symbol called? When you take this, the root, the square root, cube root, whatever, what's the symbol called? A what? Anybody know? Also starts with an R? It's a radical sign. So radical, man. Does anybody know what the little number is in the elbow? If it's square root, we don't put a number there. It's just automatic 2. It's implied, right? But it could be the cubed root or the fourth root or the fifth root. Does anybody know what the technical name for that is? Index. So if I say what's the root or what's the index, that's what I'm talking about. That little number in the, I call it the elbow. Okay, if there is no index, it is assumed that n equals what? 2. This is the square root, right? But we don't write a 2 for square root. Next section says, give all possible roots to the radicals below. Number of roots. Okay, square root of 16 is what? It's positive 4, but it's also negative 4, right? Because 4 times 4 is 16, but also negative 4 times negative 4 is also positive 16. What's the square root of 121? Positive and negative 11. What's the square root of 289? Positive negative 17. All right, a fraction. I can take the square root or cube root or fourth root, whatever it is, of the numerator separate from the denominator, okay? So think about it like this. What's the square root of 4? 2 over, what's the square root of 25? 5. Cubed root of 8 is 2. Can it be positive or negative 2? What's negative 2 times negative 2 times negative 2? Negative 8. So can it be positive or negative 2? No. When your index is odd, it's not going to be positive or negative. Okay? When your index is even, it could be a positive or a negative. What's the cubed root of 343? 7. Not positive or negative 7, just 7. What's the cubed root of negative 125? Negative 5. Now, if I said the square root of negative 125, can you take the square root of a negative? No, well, you can, but it's imaginary, right? So if your index is even and there's a negative radicand, it's going to be imaginary solution. If your index is odd and you have a negative radicand, then you can take an odd root of a negative. All right, cubed root of negative 127. What's the cubed root of negative 1? Negative 1. And we only make the numerator negative, not both. So cubed root of 27? 3. What's the fourth root of 1? Just 1? Positive or negative 1, because it's an even root, so it could also be negative. What's the fourth root of 2,401? Positive 7 and negative 7. Do y'all know how to do the fourth root in these calculators? Or the cubed root or whatever? So do the number, right? 2,401. And if you look over here in green, it has the root is x. So the x root of y, that means you can put in whatever root you want to, okay? So if I want to do the fourth root, but I want to do the green, if I don't push the second green button first, it's going to raise it to a power. But I don't want to do that. I want to take the root of the number. So if I want to take the fourth root, I put 2,401 in. Then I do second, hit that button. I put the index, or the root, is 4, equals 7, okay? So like cubed root of 20, it's not going to give you the positive and negative. It's only going to give you the positive. So cubed root of 27, I want to put 27, second, hit that button, put the index, cubed root of 27 is 3.
It also has a cube root sign.
Hmm?
It has a cube root sign.
Oh yeah, these do have a cubed root sign. So you could use the one with the cubed root, or you could do it this way. So I could do the 5th root, 6th root, 7th. I could even do square root if I wanted to, but it has its own square root button as well. So either way works. Okay, 4th root of 4,096. Positive, negative, what? 8. But my calculator only says positive 8, right? It only gives me, it's called the principal root. It's when you just take the positive. Okay, 4th root of 81/16. Well, what's the 4th root of 81? 3. What's the 4th root of 16? And can it be positive or negative, or just positive? Positive or negative. Okay, so now let's see the type of roots and the number. Type meaning is it real or imaginary, and then the number of roots, okay? If your index is an even number and your radicand is positive, are you going to have a real or imaginary root? Real. And how many roots will you have? 2. 1 positive and 1 negative, right? Even index, I get 1 positive, 1 negative, real root. What if your index is odd and your radicand is positive? So like these, what do you have? Real or imaginary? Real. And how many roots, and what's the sign? 1 positive. What if your index is odd and your radicand is negative? So like these two. Index is odd, radicand's negative. Is that a real or imaginary? Be real, right? And how many roots of what's the sign? 1 negative. What if your index is even and your radicand is negative? We did not have an example. So like the square root of -4. Oops, can't see that. Is that going to be real or imaginary? Imaginary. Anybody remember what square root of -4 is? But instead of I2, we say, no, not I2, but 2I, right? We put the I last. So that would be an imaginary. And technically, it could be positive or negative 2I. So it's 2 imaginary, 1 positive, 1 negative. So now, let's get into the meat and potatoes. Okay? Meat and potatoes. Sounds good. I'm hungry. So on these examples, I'm going to do like examples on the left and let y'all do the examples on the right later. Okay? Because the one on the left, and then you'll have the one on the right. Okay, square root of 117. Sorry, viewers at home. Is the square root of 117, is 117 a perfect square?
No.
Okay, so however you learn to simplify radicals may be different than I teach it. People do it different ways. Me personally, I use a factor tree, okay? If you can think of perfect square factors in 117 and you don't need a factor tree, cool. But the bigger the number, the more convenient to me a factor tree is. So I say, all right, 117, it sounds like it's prime, but I don't think it is. I think it's divisible by, I'm going to try 3. Oh, it is. So if I don't get a decimal, I know it works, right? So I know that 3 times 39 is 117. Do y'all remember what prime means? What does prime mean?
Like you can times.
Exactly. The only factors of the number are 1 times itself. That's it. Is 3 prime? Yes. Is 39 prime? No. What could I multiply together? What are 2 factors of 39? 3 times 13. 3's prime. Is 13 prime? Yes. So once you get all prime factors, what I do is I write all of those prime factors down. So 3 times 3 times 13. If I'm looking, if my index is 2, square root, I need 2 identical factors to make a perfect square. Do I have 2 identical factors? Yes. So instead of the square root of 117, I would substitute in 9 times 13. Double check, is 9 times 13 give you 117? Yeah, it does. If either of your factors are perfect squares, take the square root. If it's not, it's got to stay under the radical. So, what is the square root of 9? 3. Once I take the square root, I put whatever the square root is on the outside. Do I still put a 9 under the radical? No. Do I put the other 3 under the radical? No. A lot of students do. But the square root of 9 is 3. It's not 3 square root 3, is it? No. Okay. So the 9's been taken care of. Can I take the square root of 13? Does 13 have any perfect square factors? It's prime, so it doesn't, except 1, and 1 doesn't count. So 13 stays under the radical. Okay? Now when y'all do number 2 on your own, notice it has a coefficient of 4. So anytime you have a coefficient, just multiply it by whatever you take out of the radical. So say in this example, we would have started with a 4 out there, then I would just multiply the 4 times the 3 that I took out and have a 12. Okay? Look at number 3. It's the cubed root of 48. 2 times the cubed root of 48. Is 48 a perfect cube? No, Miss Rayleigh, it's not. It's not. So let me do a factor tree and see if it has any perfect cube factors. The 2 factors of 48, I might use 12 and 4. You might use 8 and 6. You might use 2 and 24. It doesn't matter, as long as they're actual factors, right? The prime factors that we all end up with will all be the same. So I'm going to use 2 and 24. 2's prime. Is 24 prime? Okay, so 24, I'll use 2 and 12. I always underline my prime factors so that when I go back and count my prime factors, I can easily, helps me not lose any. 12, I have what? 6 and 2. 2's prime. 6 factors are 2 and 3. So my prime factors, I have 2 times 2 times 2 times 2, so that's 4 2's. And a 3. You don't want to include anything that's not prime, because when you multiply all those together, you won't get 48. So 2 times 2 times 2 times 2 times 3 should give me 48. It does. I just double checked to make sure I didn't leave something out. So if I'm looking for a cubed root, I need 3 and 3 only identical factors. So I've got 4 identical factors, but for cubed root, I only need 3 of them, right? So I'll multiply those together. What's 2 times 2 times 2? 8. And then whatever's left, I'll multiply it together. Well, is 8 times 6 48? Okay. So I can replace 48 with 8 times 6, right? So this is 2 times the cubed root of 8 times 6. Now I'm going to simplify. What is the cubed root of 8? What did we multiply together 3 times to get 8? 2 times the 2 that's already outside the radical, and I'm going to show my work. Okay? Can I take the cubed root of 6? No, because 6's factors are 2 times 3. Do I have 3 identical factors? No. So 6 isn't a perfect cube. It doesn't have any perfect cube factors. So 6 has to stay in the radicand. So what's my final answer? 4 times cubed root of 6. And as long as what's in the radicand can't be simplified any further, then that's as far as you can go. Let me try to get 3 done before that next bell rings. Or, I'm sorry, 5. Alright, can I take the cubed root of a negative number? Cubed root? Yes. So I know I'm going to have a negative on the outside. So when I do my factor tree, I don't mess with the negative, because I know I'm going to take the cubed root if it's going to be negative. So 250 is not a perfect cube. Give me 2 factors of 250. 5 and what? How about, could I do 25 and 10? That would make 250, right? Okay. 10's factors are 2 and 5. They're both prime. 25's factors, 5 and 5. So my prime factors are 2 times 5 times 5 times 5. Is there a perfect cube in negative 250? Yes. That perfect cube would be 5 raised to the third power is 125. So is 2 times 125 250? Okay. So I'm going to replace that. And I already took the cubed root of the negative, so that's already on the outside. Okay. What's the cubed root of 125? 5 times the negative sign that I already put out there. Okay. Can I take the cubed root of 2? 2 is prime, right? Its only factors are 1 in itself. So can I take the cubed root of 2? So what do I do with the 2? Stays under the radical. That's all I can do. For you sleepers in here today, don't ask me for help when you don't understand this. All right, let me see if I can get this one finished real quick. Is 162 a perfect fourth? No, if I get a decimal, it's not. So I'm going to do a factor tree and see if it doesn't have 4 identical factors, then we can't simplify it without being a decimal, and we're not doing decimals. So 162, let's see, it's even, so I know it divides by 2. So 2 times 81 is 162. 2 is prime. 81 factors, I'll go with 9 and 9. And both of those 9s have factors of 3 times 3. So my prime factors have 2 times 3 times 3 times 3 times 3. Does 162 have a perfect fourth factor? Yes. So all of those 3's together, if I multiply them all together, I get 81. So 81's a perfect fourth, right? So that's 3 times the fourth root of, instead of 162, I will substitute that with 81 times 2. There's already a 3 out there, so I'm going to multiply 3 by anything that I take out. What's the fourth root of 81? 3. So I'll multiply those together. We know that 2, does it have a perfect fourth root?
No.
So the 2 stays under. And what's my final answer? 9 times the fourth root of 2. Okay? So I'm going to pause this video. And when we come back from lunch, we'll continue.